This video is for navigation for the E6B problem sheet that I gave you. I'm going to go through how to do each of the problems. I'm not going to do all the problems, but I'll give you the method of doing each of the problems. So for number one, of course, I gave you all the answers here. So hopefully you went through and did it and then use that to check your answers as opposed to just putting the answers in. When you have a ground speed, distance, time problem, when you're finding time from ground speed and distance, what you do is, for example, let's do the first one. Notice we have knots and nautical miles. Miles per hour, statute miles. So just notice that the units go together. So if I'm going to go 80 knots over the ground, how long is it going to take me to go 300 nautical miles? Well, let's look. Okay, 80 knots, 300 nautical miles. So you just use the index here and put it on 80 knots. Remember that the triangle here, 60, is per hour. So you want that exactly on the 80 knots here. And then you want to find out, all right, how long is it going to take me to go 300 miles? Remember, the A ring is the miles, and the inside ring, the B and the C rings, are your time. Okay, so since I've already got it on 80 nautical miles per hour, you can see I've got it set there. All I got to do is come over to the 300, okay, and come right down, and it's going to be 3 hours and 30 minutes, 40 minutes, 45 minutes, 50 minutes, 4 hours. So it's about 3 hours and 45 minutes. And that makes sense. You're going to do 80 nautical miles in an hour. To do 300, it's going to take you a little bit over 3 hours. So there's 3 hours and 30 minutes, 3 hours and 40 minutes, 50 minutes, 4 hours. So right here, right at 3 hours and 45 minutes. So that's how you do a speed, distance, time problem. Okay? Or it also turned out to be 225 minutes, or 3 hours and 45 minutes right here. Okay? Number two. That's how you do all those speed problems. All right. For number two, we want to find how far you go if you're traveling a certain speed in a given time. So let's go down here. We're going 95 knots. How far am I going to go in 17 minutes? So it's basically the same method. Now you want to go 95 knots, which there's 9 and 5, and we'll put it right there. Okay, and I'll make that bigger so you can see it in a second. And how long is it going to take me to go 17 minutes? There you go. All right, so I've got it on, you can see I've got it on 95 knots. And now I'm going to read time off the B scale. All right, right there. There's the 17 minutes. I'm going to go about 27 miles. Okay, now notice right here, there's the 17 minutes. Read straight out to the outside for your distance. It's just maybe a tenth less than 27 miles, 26.9. So right about 27 miles. That's how you'll do finding distance from ground speed and time. Okay. Number 5, down here. We want to find ground speed now given distance and given time. So it's exactly the same type of problem, but now you're going to use your A and your B rings, and then you're going to go back and find the reference spot there to find how fast you're going. Okay, so let's go down here. Of course, if it was statute miles, it'd be minutes, and miles per hour. All right, nautical miles will be nautical miles per hour. So let's go, I'm going to go 15 nautical miles in 9 minutes. Okay, so what's my speed? All right, so I'm going to go 15 nautical miles in 9 minutes. All right, let's go right there. All right, so 15 nautical miles is right here on the outside. And 9 minutes, I'm just going to move and put the inner ring to 9. There we go, 9 minutes. So you can see I've got it lined up 15 miles in 9 minutes. Okay. So then I just go straight over. Let's slide it up a little bit. There you go. I go over to the index ring, how many X number of miles per hour, nautical miles per hour. So you can see right here, I'm going 100. 100 nautical miles. Well, it's 10, but it's actually 100 nautical miles. Okay? So if I go 15 nautical miles in 9 minutes, I'm going 100 nautical miles per hour. Okay? And that should make sense to you. All right? The hardest part of figuring this out is it going to be 100? It's going to be 10? A lot of times, you've got to figure out the decimal point. And so do what makes sense. Now doing fuel consumption rate is exactly the same thing. Instead of miles nautical miles per hour, you've got, 17 gallons per hour. And you've got a time. And so you can find the fuel used. So it's done exactly the same way as you would do any distance problems. Okay, so let's do one right here. I've got 7 gallons per hour. So when you see the pH or per hour, always you're using the index. And I'm going to do that for half an hour. Now in your brain it says, all right, 3.5 gallons. I'm going to use half of the 7 gallons per hour. But let's do it on the E6 and prove that it actually works. So 30 minutes burning 7 gallons per hour. Okay. All right, so get 7 gallons per hour. I'm going to twist the index around to 7. So there's 7 gallons per hour right there. All right. 7 gallons per 60 minutes, 7 gallons per hour. And then I'm going to go over here to 30 minutes and read down. Okay? Okay, where's 30 minutes? Right there. All right? There's your 30 minutes. Remember, you're reading time off your B scale. And go straight up. There's your 3.5, 3.5 gallons. And really, you just have to figure out your decimal point. Okay? Again, gallons per hour, right here. And then you go, if they give you a time, you go to the B scale, and they can give it to you the minutes, or in 5 hours, I'm going to burn 350 gallons, right? Or, excuse me, 35 gallons. Okay, that decimal point got me too. All right? So 3.5 gallons in 30 minutes. All right? All right. Well, let's figure out if we're giving you the consumption rate, again, gallons per hour, and you got X number of fuel. So if I'm burning 10.6 gallons per hour and I got 50 gallons, all right, how long can I fly? How many minutes can I fly? In this case, we'll have to look on the E6 just like we did. So let's go. We're going 10.6 gallons per hour, and we're going to burn 50 gallons. Okay, so 10.6 gallons per hour. So I'm going to go around here to a little bit more than 10.5, which is one tick more right there. There's my tick right there. 10.6, there's 10.5, 10.6 per hour. Okay, and I'm going to burn, again, 10.6, 50 gallons right there. All right, so let's go back. All right, so I want to go around to 50 gallons, read around right here. There's my 50 gallons. How long is it going to take me? All right, well, 4 hours here, or 4:30 here, 4:40, 4:50. So it's right around 4:45. Okay, 4 hours and 45 minutes, give or take a little bit, or 283 minutes. You can see if you read it on the minute scale right there. Okay, so that's how you do that. They're done exactly the same as your distance problems. All right, last one here. We want to convert, knowing the temperature and the pressure altitude. If you're reading a airspeed on your airspeed indicator in the airplane, the higher you go, your true airspeed is going to be faster because the air is thinner. Okay, so it's going to change from with the temperature and with the pressure altitude change. So your true airspeed is going to be a little bit different based on the temperature and the pressure from what you're reading in the cockpit. So how do I do that? Okay. The scales that you use are on the inside. Okay. These are the scales right here that you use to convert right here. Okay. So you can, if you twist here, the outside scale here is your temperature scale. Okay. The inside scale is what you would read for your altitude. So say, for example, let's see what our example problem was. All right, I've got a temperature of 10 degrees outside and a pressure altitude of 4,500. What is my density altitude, or what altitude is the airplane really seeing? Okay, so let's figure that out. 10 degrees, 4,500 PA. All right, let's go back up here. All right, 45 degrees is right here. Now keep in mind the positive's on the left-hand side of the 0. Okay, so there's about 10 degrees right there. And then you want to go all the way around to 4,500 feet. There's 5,000, 10 degrees, and the first tick marks are one each. So you're going to go right 10 degrees and about 4,500 right there. Okay? So there's your pressure altitude at 4,500, and you're matching it with 10 degrees. So you'll read the density altitude just a tiny bit less than 5,000, about 4,900 feet on this outer scale here. It says density altitude. So on the outer scale, you will read what the DA is. So it's about just one tick less than 5,000. Okay, so it's about 4,900. Now, to figure out my airspeed, okay, if I'm indicating 95 knots, then how fast am I truing through the air? So what I'll do for that, I'll go up here to 95 knots, right here on the B scale. And then I'll read out. And that tells me I'm really going 102 knots. And let me make that bigger so you can see it. Okay, so I don't move the scale at all once I match up and get my DA at 4,900 here. So I go around to the B scale, okay, and there's my 95 knots, halfway between 9 and 10. And then I read the outer scale, there's 102 knots right there. So if I'm indicating 95 knots in the cockpit, then I'm actually going 102 knots through the air. Now we'll talk about making wind corrections and like that when we do our flight log, but that's how you get from calibrated airspeed to true airspeed. That's how you get from pressure altitude, changing it with the temperature, for your density altitude. And when you do nav logs, you'll need to do that for your flight planning. Okay? All right. And we'll talk about, last thing is converting our 5 degrees here to our magnetic heading and our ground speed. So we'll talk about that when we do our logs. Okay.